Here, how you join, but did not start. Okay. How you join here in this Zoom? Just with your with my ID and passcode. Okay, okay, okay. Right. Before joining, are you signing in into the this meeting in your Zoom? Means, do you have Zoom account? All of you. Uh, Before logging in. Yeah, yeah. With your Google account, initially you have to sign in. But tomorrow, from tomorrow onwards, you have to sign in, Nana. I'm restricting, like how I took my first class. Okay, without signing in, you can't enter into my this Zoom class. Yes, you must. Okay. If you are unable, then no problem. You can watch the class in YouTube, Nana. Already, I'm giving the live class in the YouTube also, na? So if you are facing any problem, then you join there. You watch my class in YouTube. Okay, na? Right. Don't create any trouble tomorrow if you are not able to join here in the class. Okay. Right. Okay. If you are unable to join here in the Zoom, then watch in YouTube. Why? Because there is an alternate option. Okay, na? Don't make it trouble and don't post anything to Sharad sir or HK sir in the middle. Okay. Right. Good. Why? Because we are facing few problems, Nana, here. The other students are joining here and creating trouble. Yeah, unknown members creating the trouble in all classes, not only in your class, in all seniors classes and all classes. That's why I'm providing more restrictions here. So better you sign in and then join in my class. Yeah, yeah, right. Right, right. Good. Then come to here. Yesterday, sure, right. Yesterday, I think I discussed something about torque and angular momentum and the equations of motion also, I think. Okay. From the torque and from the angular momentum, we got torque is equals to, okay, right, right, no problem, Nana. Okay. Okay, okay, then no problem. Right, right, right. Good. Likewise, if everyone signed in, then there is no problem. Sharma. Okay, good. Then here, yeah. First one is torque is equals to, yesterday we discussed, right, good, Ishan, I alpha. And angular momentum, we discussed it as I omega. Okay. And then here, relation between these two also yesterday we discussed. And it is tau is equals to, that is I omega, correct. Tau and angular momentum relation. Tau is equals to d by dt of angular momentum, L. Tau is equals to dl by dt. Okay. And here I gave few equations of motion when a body is moving with the constant, rotating with constant angular acceleration. Alpha equals to constant. Then I gave there like omega equals to omega naught plus alpha t. Theta is equals to omega naught t plus alpha t square. And here v square minus u square, that is omega square minus omega naught square equals to 2 alpha theta, and theta n equals to omega naught plus alpha by 2 into 2n minus 1. These were the equations given yesterday in the class. Yes, good. A small recollection. Okay, recap. And here now we are entering into how to use these formulae to solve the numericals. Okay. In what way they are helpful in solving? These equations are helpful in solving the numerical. Okay. Suppose I say a body is better. I send one assignment now. Better we try to solve from that assignment now. Okay. I will try to open that assignment. I'm going back. And here trying to share that assignment. I think this is the assignment what I sent. Correct, Anana? You will try. Okay, you try. But just one or two problems I will solve. Just to get some clarity. Okay, na? Right? Right, good. So here, come to this one, Nana. Look at the rotational kinematics part. Okay. This is a ceiling fan is rotating about its own axis with uniform angular velocity omega t. The electric current is switched off. Switched off means it tries to stop or tries to increase its angular velocity. Stop means it decreases. Decreases means alpha is negative. Keep in mind. Okay. And here switched off, then due to constant opposing torque, clearly he mentioned here, its angular velocity is reduced to 2 omega by 3 as it completes 30 rotations. These things you have to understand now. Okay, properly. What he gave there clearly and try to understand. Initial angular velocity omega naught is given. How much? Try to identify here in the question. Initial, is it omega or 2 omega by 3? Isha, is it correct? Deepali? Initially, it is rotating with this angular velocity, kadana. Due to the opposing torque, angular velocity is finally reduced to 2 omega by 3. So, final angular velocity is 2 omega by 3. Initial angular velocity is omega. Correct? It is reduced from omega to 2 omega by 3. Right. So initial one is omega, final one is 2 omega by 3. Okay. And here the number of rotations further it makes before coming to rest. Very good. Here the number of rotations, that shall I take it as theta equals to 30 nana here? Yes, exactly, Deepali. That formula only we have to use. 24 is the answer. Okay, we will check it. 30. Okay. Here theta 30. Yeah, 24 means how you got directly that the answer is 24, Nana? I think we have to solve two equations here from the first information, from the last information. So first we have to write omega square minus omega naught square equals to 2 alpha theta. Equation 1 I am getting here, omega square is square of this one, 4 omega square by 9 minus omega naught square, that is omega square, equals to 2 alpha is negative minus alpha into theta. How Nana 24? How that much easily you got the answer? All of you are saying 24 here. Okay, what will be the second equation? Sharma, correct. That is the first equation. Uh, 5 omega square by 3. I don't think it's so 9, no, 9 minus 5 omega square by 9 kadanana. 5 omega square by 9. 9 minus 5, 4. 9 minus 4, 5 kadanana. Minus 5 omega square by 9 equals to minus 2 alpha theta. This is the equation 1, what I got here. Will anybody say what the second equation you got there? Good. Yeah. Second equation, Sharma, correct. Yeah, oh, here theta, I did not substitute. Okay, right, no problem. This is minus 60 alpha, right? 2 alpha theta is 30, right? Accepted, first one. Second one here, it is now rotating at 2 omega by 3, finally stops. Means its angular velocity reduced from 2 omega by 3 to 0. That is here omega square, 0 square minus omega naught square, 4 omega square by 9 is equals to minus 2 alpha theta. Now we simply, if you divide the two equations, you will get the answer. 5 omega square by 9 divided by this is minus 4 omega square by 9 is equals to right hand side minus 60 alpha divided by minus 2 alpha theta, second equation. Okay, this is 1 divided by 2. I think now you will get it is maybe 24, I think. Okay. 5 ones are 12, 12 fours are 48, 48 by 2, 24. Yeah, by solving these two equations, you will get. That implies alpha here cancelled, theta equals to, you will get 24. Okay, good, correct. Now you understood how to solve these kind of questions, Nana? Do we have any student like Sarayu T in our college? Yes, okay then. Right. Then here, will you solve these more all the problems, Nana? First, try to solve 19 to 34 first, Nana. Oh, why? Because related to moment of inertia, I think you can solve. Okay, till 34, the questions will be direct formula based. From what I am saying, 19 to 34. This is moment of inertia. Okay, no problem. Today you try to solve them. Okay, then come back to this part. What this rotational inertia? Sorry, not this one. What we tried here. Rotational kinematics, torque, mechanical equilibrium. Then come back to this part. Okay. If you are interested, then try to solve the center of mass questions also. Cross product, and I give the different questions there. Okay. Right. Even here also, Nana. 12 and 13 also. Okay. Like those equations. 4 equations are then from there you can solve. 12 and 13. Okay. Shall I move back to my whiteboard? Yes. Okay. Right. Yes. Coming back to here, this whiteboard. And here we are trying to do few questions. Okay. To get some idea. Suppose in the numericals, if they say the angular momentum changes from 10 to 20 kg meter square per second, then in a time of 5 seconds, find the torque. Then what do you say the answer for this question? Anybody here in the class? Oh, Amok. Exactly. Others? Okay, I think did not get the idea for that. Okay, no problem. Look at what the information given. I think you will get some idea. Angular momentum changes from 10 to 20. Means initial angular momentum, he gave it as 10. Final angular momentum, 20. All that happens in a time of 5 seconds. Yes, now I think you got the answer. Yes. Varshit. Lakshmi Gayatri. Okay, right, good. Yes. Now the angular momentum changes in a time means, look at here, the torque is related to the change in angular momentum as tau is equals to dl by dt. Directly he give the change. That's why directly you write it as delta L by T. Okay. Delta L is 20 minus 10, L2 minus L1 by time is 5. Sorry, 20 minus 10 divided by 5. That is 10 by 5. If you already got the answer, that is equals to 2 torque Newton meter, not joules. So understood this problem, Nana? Here rest of the students able to understand? Yes, okay, good, good, good. Sometimes like without using any differentiation, we will get the answers like simple, in a simple way. Okay, yes, good, Sharma. Okay, when we use this short method like delta L by T, provided they give the initial value and final value. Suppose if they give the angular momentum in terms of time, then there is no other chance for us. We have to differentiate that equation. Okay, then look at the second example here. Yeah, I think you can understand. The second example, the angular momentum of a body changes from changes as L is equals to like some 20 t square or else 20 sine 3t. Okay, suppose if they ask find the torque at t is equals to pi by 3 seconds. Okay, then here there is no other way. Okay, why? Because it is changing with the time. If L is variable, changing with the time, we have to differentiate. So obviously we have to come to the method tau is equals to dl by dt. Yeah, exactly, Amor. Correct. Tau is equals to dl by dt. Okay, so differentiation, I think already started in mathematics and you know the differentiation how to do. Yes, correct, Lakshmi Gayatri. Lakshmi Gayatri, I think went wrong now. Somewhere he did the mistake. Did the differentiation properly? 20, yes, 20 is correct, Sharma. 20 sine 3t here. Okay, 20 taken out, differentiation of. Is it plus 60 or minus 60, Srestha? Sine 3t. Yes, yes. 20 into sine, yeah, sine differentiation is cos 3t. I think here you forgot Lakshmi Gayatri. Cos 3t, differentiation correct. But inside term also again we have to differentiate now. That is d by dt of 3t. That you will get, yeah, minus 16. Now it is correct. Okay. Okay. Yes. 33 is a 60 cos 3t. This is the torque, correct. He is asking at t is equals to pi by 3. Substitute t is equals to pi by 3. At t is equals to pi by 3, we write torque is equals to 60 cos 3 t is pi by 3. Then you will get cos pi, that is how much you know, minus 1. So torque is equals to minus 60 Newton meter. Now it is correct. Yeah. I explain both the methods here. Okay. All right. And then here come to one more model. Try to understand this model properly. A body is projected torque should be negative, na? Opposing torque may be negative, na? Sharma? Not time. Time already I took it is positive time only, plus pi by 3. Yeah, time is plus pi by 3. Torque may be negative. Okay, accelerating torque, decelerating torque. Decelerating torque is negative. Yeah, okay. A body is projected from the ground level obliquely, means making an angle at an angle like some 45 degrees with the horizontal. Okay. Velocity of projection, you take it as u. He did not give that value in the question. Okay. First simple thing is about the point of projection. Find the torque and angular momentum both. At what point? At the highest point. Okay. At the highest point, find the torque and angular momentum. This is the question. So how to solve it? Okay. First, we have to draw the diagram for the question. Draw it. A body is projected obliquely. Okay. Follows one parabolic path like this. All of you know it. He is asking at which point? Exactly at the highest point. What he is asking? Torque and angular momentum. About which axis? Why? Because torque and angular momentum, both axes is important. About the point of projection. This thing you have to understand. About the point of projection. About the point of projection means, Are Badudai, take the axis at the point of projection here, perpendicular to the plane, like the z-axis. Okay, now you understood what he said. Okay, axis is assumed. Yes, axis is assumed. At where? What he said, the point of projection, according to the question only. At the point of projection. How? Perpendicular to the plane of this projectile. Perpendicular. Suppose it is x-axis. And that one, if you take it as, yeah, thank you, Sharma. This is y-axis. Then, yeah, the angular axis of projection, we are taking along z-axis. Okay, perpendicular to the plane. Axis is assumed at the point of projection along the z-axis. Okay, that is perpendicular to the plane. Okay, So this is the axis now. So here find the torque means, I think tau is equals to I alpha is not helpful for us to find out the torque in this case. Why? Because I don't know the alpha. Anywhere alpha is not given. Okay. If it is failed to find out the torque, then I go to the other equation of torque. The other equation torque is equals to, for a point mass, we wrote R cross F na. That is F into perpendicular distance, the magnitude is. Remember this formula, Nana? Yesterday only we discussed. Yes. Okay. Since this formula is not helping me here in solving the torque, so I am going to the other equation. This is the way how to go from one to the other. Okay. If one formula, oh, that is not helpful, then try to search for another formula. Okay. Sir, even in this formula also, how to write the force, how to write the perpendicular distance, sir? Very simple, Ranana Badudai. Think wisely. Here it is projected into air na. Yes, sir. After projecting in air, its weight acts in what direction, Nana? Downwards, sir. Okay, Nana. This is downwards. Weight. Who is the weight? Weight is a force, sir. Then why you asked me, Badudhai? F is how much here? Oh, I understood, sir. Force is mg na. Yes, master. Ah, Ishan. Ishan, you are very good in English, Nana. Okay. Sorry, sometimes it happens. Okay, you are my heart, na. Try to understand. Okay, right. Okay, right. At the point of projection. Good boy. Then come back to here. F equals to mg. And where is the axis? Axis is taken here. So next your job is finding out, not the spelling mistakes, finding out the perpendicular distance. Okay. Perpendicular distance from axis to the line of, no, Lakshmi Gayatri. Perpendicular distance, Nana. From the line of action of force, we have to draw a perpendicular to the axis, Nana. Perpendicular means, will you get this part is the perpendicular or that part as the perpendicular from axis? You only see there. X-axis, along the x-axis now. So I think maximum height is not the perpendicular distance. Am I right? Okay. So along x-axis only, that will be the perpendicular distance. So I think it is the perpendicular distance from the axis. All of you followed this point, Nana? Okay. Yes. Look at that perpendicular distance from the figure. I write here. Perpendicular distance is equals to, look at that is Amol, correct, half of the range. Exactly. In the total range, it is half up to the maximum height. Exactly. Half of the range. Perfect. Where R is the range. Oh, I have to write here where. Otherwise, Ishan again will ask. Okay, where R is the range. Okay. Okay, Ishan. Right. Next. Here the force already I gave there. F is equals to mg. I think now it will be very easy to find out the torque. after coming to know the things in the formula. Okay, that implies torque magnitude is equals to force into perpendicular distance. Okay, so here force is mg, perpendicular distance is half r, that is mg by 2 into r. I think all of you remember this one from motion in a plane range formula. Is it correct, Nana? Yes, correct. So sine 2 theta, theta he gave, exactly. G get cancelled. I'm getting just like half mu square since theta equals to 45. Okay, sine 90, that becomes 1. Oh, thank you, Sharma. Torque is equals to half mu square. Okay, so sweet, thank you. Right, this is the torque, Nana, first one, what we calculated. And look at the second one here. He is asking angular momentum. This one, take care. Angular momentum, again, L equals to I omega. If you use, you can't find anything. Why? Because again, omega in the problem anywhere not given. So better we go to the another formula. What is the another formula of L? L is equals to R cross P. Okay, in vector form. Its magnitude is equals to, here we write P into perpendicular distance. Okay, so P into perpendicular distance here. P angular moment, linear momentum, where at highest point, velocity, yeah, we recollected, sir, not 0, Mr. Amog. Amma Amog said wrong today. Yeah, lion the king. Okay, God the Amog. Yeah, Lakshmi Gayatri, yeah, Amog, second time you recollected correctly. Yeah. Very good. And sometimes it happens, Ishan, we have to accept. Yes, you're right. So here, this is the direction of velocity. I think all of you remember at the highest point. Yes. Just because we are humans. Okay. Who will do the mistakes? Humans only. Yes, you're right, Mr. Shan. So here velocity will be u cos theta at the highest point, not 0. Yes. And linear momentum is product of mass to velocity. So linear momentum P at the highest point is mu cos theta. Okay. Look at it. Mu cos theta is a horizontal, means acts along this line. Okay. That is going to Kanyakumari. Okay. Right. Better. This is the line of action of linear momentum. Now drop a perpendicular to this line from axis. Is this the perpendicular distance? Perpendicular to the green line? Y-axis. Very good. So this time we have to take it is the perpendicular distance. That perpendicular distance, once you check up to here, exactly perfectly matching with the maximum height. Exactly. Yes, correct. H. Okay. So if you come to here, the perpendicular distance that equals to H. H is equals to, I think all of you remembered, u square sine square theta by 2g. Is it correct, Nana? Yes, exactly. Already you posted. Very good, very good. And here u square by 2g into sine square theta. Sine square 45 is 1 by 2. Okay. Since theta is equals to 45 degrees again. That is u square by 4g finally. Okay. So that implies perpendicular distance is equals to, I am getting here, u square by 4g. Okay. And linear momentum P is equals to, already I wrote there in the diagram, mu cos theta. That is mu cos theta is 1 by root 2. Again, since theta equals to 45 degrees. Okay. Therefore, you can write the angular momentum. It's very simple. You can understand. Angular momentum L is equals to P into perpendicular distance. Very simple. So P is, now I'm going to substitute mu by root 2 here, and perpendicular distance u square by 4g. So finally I'm getting the answer mu cube by 4 root 2 into g. This is the angular momentum. Okay, this was the question previously given in many exams. Okay, advanced, mains, even in MSET also, they asked this direct formula. At highest point, what is the angular momentum? Okay, already given. This one, not in advance, given in mains. What is the torque at the highest point? So the two questions what he gave in exam today we discussed. Torque to angular momentum at the highest point. Okay. If it is not the highest point, then how to calculate? Okay. If possible, you try it at home. Otherwise, I will explain that tomorrow. Okay. Just I will give some hint here. I am asking what I am asking. After projecting at some point here, after a time t is equals to t. Okay, what is the angular momentum and what is the torque? Okay, so writing here the question, find the torque and angular momentum after a time t. Means that is not the highest point, that is not here at the point where it lands, somewhere in between, anywhere here, there, here, or here at some other point. Okay, right. Any doubts in the today's class, Nana? Do you have any doubts? No doubts? Okay. Then again, yes, Ishan. Yes, Aditya. Take the pages, Nana. Thank you. Bye, Nana. Bye, everyone.